Angles can be measured in degrees or radians. Most people are more familiar with degrees, but you are going to have to use radians a lot if you plan to take calculus, so I'm going to try and focus us on radians this semester. What is a radian? A radian is the ratio of the distance traveled by a point around the edge of the circle to the radius of the circle. You're thinking, how far does the tip of the minute hand travel in 15 minutes versus how long is the minute hand? Using that definition, we can figure out how many radians are in a circle, no matter what the circle is. So radians are, we're going around the edge of the circle versus the radius of the circle. So how many radians are in a full circle? If we go around the edge of a circle, we're going around the full circumference. Remember that word from 5th grade? Here's the formula for circumference. So it's how far we travel around the edge of a full circle versus the radius of the circle. Hey, notice that r is on top and on bottom of the fraction. They cancel each other out. So no matter what the radius is, there are 2 pi radians in a circle. All right, we're going to use that fact when we convert back and forth between radians and degrees. So there are 2 pi radians in a circle, and I think most people are aware that there are 360 degrees in a circle. You can use that as your conversion factor. I tend to do that because I just think in terms of full circles, but you can also say there are pi radians in 180 degrees. So cut both of those in half. It just gives you a little bit simpler of a fraction to deal with. Make sure you include units. A lot of times we can tell that something is a radian because it has a pi with it, but technically you could just say we have 2 radians. 2 radians is different from saying we have 2 pi radians. So generally the pi is a hint that we are in radians, but you need to make sure that you write out the unit radian or RAD just to be super clear, as opposed to if I had just written we have 2 degrees. Well, you have to make sure you write your degree symbol or write degrees out. Versus technically you could have 2 pi degrees. That's a really weird, and I'm not going to give you that, but just know that that's a possibility. 2 pi radians, 2 times pi, I think y'all know that pi is 3.14. So 2 times 3.14 is 6.28 da 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 da. So 2 pi is an exact answer, but if I wanted to just kind of estimate and give you a real world decimal version, I would say that's 6.28. So know that this is the exact number if I use pi, the pi symbol, and this is the rounded number if I use 3.14 instead of the pi symbol. That's important. Most of the time I want exact answers with pi included in them. Let's do some examples of converting, and maybe it'll be a little clearer about exact answers versus rounded answers. Example 1, convert. Give both an exact answer and a rounded answer. We're going to start with 30 degrees. I like to use t-tables because many of y'all are also in chemistry and you use t-tables in chemistry. So I draw a t-table. We're starting with degrees, which means I want to get rid of degrees to convert to radians. So I need to put degrees on the bottom to cancel out with my degrees that's already on the top. And I'm trying to convert from degrees to radians. Okay, so now for a minute you just ignore all this and you say, let me think of some kind of conversion factor. How many radians are in a degree, or how many degrees are in a radian, or can I think of some equivalent measurement? You can either say 2 pi over 360 here, or just pi over 180. Most of your YouTube tutorials use pi and 180, so I'm going to stick with that just in case you want more examples from YouTube. You'll be not so confused. Okay, so to come up with an exact answer here, you do not type the pi symbol into your calculator. You just type the numbers. And to deal with the t-table, you multiply everything in the top and divide by each piece in the bottom of your t-table. So if I had multiple pieces down here, I would divide by each one separately. Okay, for an exact value, you just type the numbers in. So 30, there's no other number on top. The pi is a symbol. So I'm going to divide by 180. All right, well, that gives me the decimal 0.16666. Math, enter, converts that to a fraction for you. So that is 1/6. So the exact answer here is 1/6 pi, or pi over 6. Or, it's not really exact, but it's the 0.166666667 pi. So all of these are kind of a form of the exact value because it uses the numbers I converted and then I left the pi symbol in there. Versus the rounded one is, now that I know that it's 1/6 pi, well, what's 1/6 times pi times 3.14? Oh, 0.5235, I always round to 2 decimal places. So exact values use the pi symbol. Rounded values, we actually type pi into our calculator, so we multiply by 3.14159 to get a decimal answer. Do not include the pi symbol for your rounded answer. Let's do another example. Convert 82.5. I'm going to draw a t-table. I'm starting with degrees, so I want to cancel out degrees, so I need one on top and one on bottom to cancel each other out. And I am converting to radians. Ignore this for a minute and think, how many radians are in a degree, how many degrees are in a radian, or is there some kind of equivalent measurement? Okay, there are pi radians in 180 degrees. All right, for an exact value, just type the numbers into your calculator. 82.5 times any number you see in the top. I just have the pi symbol. I'm not multiplying by anything. Divide by each term you see in the denominator, so I only have that 180 in the denominator. And math, enter, converts this to a fraction. All right, to get my rounded answer, instead of using the pi symbol, I want to actually multiply this 11/24 by pi, or multiply it by 3.14159, and you get 1.44. Okay, just for me to be clear, most of the time we're going to be using the exact answer, but I want you to practice finding the rounded answer because in real life, if you ever do anything with radians, you're going to want the rounded answer. Why would I tell you to walk pi miles when I could just say walk 3.14 miles? That makes so much more sense in the real world. All right, last example is let's convert in the other direction. And luckily here, we don't have exact versus rounded degrees, so we just have to do some multiplying. All right, let's convert negative pi over 3 radians to degrees. So again, I'm going to come up with a t-table. My fraction bar here is going to become my t-table. All right, this is pi over 3 radians. So I'm starting with radians. I want to put radians on the bottom here so they'll cancel each other out. And that means I need to get to degrees. So then think through how many degrees are in a radian, how many radians are in a degree, or is there some kind of equivalent measurement here? So there are 180 degrees in pi radians. You could also use 360 and 2 pi and it will give you the same answer. Let's multiply this out. You could realize that your pi on top of your fraction cancels with your pi in the bottom of the fraction, so you just have negative 180 over 3. If math is not really your thing and you didn't recognize that you could cancel those things, let's just use our calculator to do everything. Negative pi, multiply by everything in the top, divide by each piece in the bottom separately. So I'm going to divide by 3 and now divide by pi. And I get negative 60 degrees. Make sure you include units for all of these, which is not what I did at all up here. It's always a good idea to include units just so you don't get confused between radians and degrees. Let's do another example of converting radians to degrees. We're going to convert 6 radians to degrees. Okay, so we have 6 radians. I'm going to make my t-table. Radians is on top, so we need to put radians on the bottom of our t-table so they'll cancel each other out. And we're converting to degrees. Okay, ignore this. There are 180 degrees and pi radians. All right, let's multiply this all out. So 6 multiply by every piece in the top of your t-table and divide by every piece in the bottom. Divide each piece in the bottom separately. And you get, I don't have to worry about exact versus rounded here because in degrees they're always just rounded decimals. And we're done. Make sure you didn't try and put a pi here because there was not a pi in the original problem. It was just 6 radians, so leave it as just a 6. Don't try and make that a 6 pi and make your pi's cancel.